Well, welcome everyone. This video is going to go over how to solve a linear system of equations by graphing, and we're going to be looking for the intersection point. And if we find an intersection point, then that will be an integer solution, and we'll take those two integers and we're going to check them against the original problem. So it says find the solution to each linear system, rewrite each equation in slope-intercept form. So that's the first step that we always need to do. Carefully graph the equations by showing all possible integer solutions. Identify the intersection point, identify the x and y coordinate for the ordered pair, and then last of all, check the solution by substituting the values into the original equation. So let me bring up my layers here, and we'll go ahead and start with number 1. So I've got a negative 1x plus 3y equals 15. So we're going to rewrite this in slope-intercept form. I'm going to go ahead and use red. So I've got a negative 1x plus 3y equals 15. And we're going to add 1x to each side. And when you take the 1x to each side, because that's going to go to 0, so it's going to be gone. That leaves me 3y equals 15 plus 1x. Now I'll divide by 3. So now my final equation is y equals 1 over 3x plus 5. Now we'll do the equation B. I'll do that one in black. I've got a negative 3x plus 2y equals a negative 4. We'll add the x term to each side, which that's what we always do, is add the x term to each side first. That cancels the 0, so it's gone. Then we divide by the number in front of the y. So that equation is y equals 3 over 2x minus 2. Now we'll graph each one of these equations. We'll graph equation A first. So we start at 5 on the y-axis. And we count down 1 over 3. Oh, don't want to go down. That's a negative slope. Negatives go from left to right. They go down. This one is a positive slope. So I need to go up 1 to the right 3. Up 1 to the right 3. Up 1 to the right 3. Down 1, back 3 squares. I want to count the squares, not the lines. Down 1, back 3. So there's that line. There we go. A little bit off up there, but it's close enough. Well, why don't I just take that off and we'll get it a little bit closer. There we go. So that's line A. And now we're going to do B. We'll do B in black. So I've got started a negative 2. This is a positive slope where I go up 3 to the right 2. So 3 squares up, 2 squares over, 3 squares up, 2 squares over, 3 squares up, 2 squares over. That's where the two lines intersect right there at that point. Do the other way, down squares, down 3 squares, left 2 squares, down 3 squares, left 2 squares, and so there's my second line. Guess I have another point way up there, don't I? So I've got one there, and I have one down there. So there's my equation for the second line, line B. And then if I look right here, there's where the intersection is, and that looks like that's the point 6 and 7. Now because 6 lies on the black, 6 and 7 lies on the black line, it lies on the red line, it's a solution to both lines, to both equations, because it lies on the line for this equation, it lies on the line for this equation. So I know x equals 6 and y equals 7, so I'm going to take a negative 1 times an x that'll be 6 plus 3 times the y. 3 times the y will give me 7, and that's supposed to be equal to 15. So negative 1 times 6 is a negative 6. 3 times 7 is 21. Negative 6 plus 21 is 15, and we know that 15 does equal 15. So that means we've done the one side right. Now let's do this other equation and test it. So I have negative 3 times x. X is 6. And I have plus 2 times y. Y is 7 equals a negative 4. Negative 3 times 6 is a negative 18. 2 times 7 is 14. Negative 18 plus 14 is a negative 4. And a negative 4 does equal a negative 4. So that means I've got the correct solution. So the next problem that we're going to do is number 5. And number 5 is a hard one. And we'll start that in just a minute. So here we're on number 5, and I'm going to skip some of the algebra. I'm just going to do this in my head, doing this algebra. So I know I'm going to move the 2x, negative 2x over across the equal sign, so that's going to make it a positive 2x. And I'm going to divide that by 8. Run out of room there. So that'll be y equals 2 over 8 x, and 8 divided by negative 64 is a negative 8, and I'm going to simplify that further. 2y equals a negative 1/4 x minus 8. This other equation will be y equals, so that's going to change sides, so that'll be 4 divided by 2, that'll be 2 over 1x, and then 2 to the negative 44 will give me a negative 22. So now you can see right here, this is the y-intercept. That's way off the graph. A negative 22 on the y-axis would be way down here. So I can't use this equation to graph, but I can graph this one. So I'm going to graph equation A first. So I go down a negative 8, and then I go up 1 over 4, up 1 over 4, and then down 1 to the left 4, down 1 to the left 4. So we'll graph this first equation, and I'll show you a trick to graph the other one that will help you. And then we'll go ahead and check that line. So there's the line for the first equation. Equation A. Now we're going to go ahead and do the line for the second equation. Now what we're going to do on this one, so what we're going to do is we're going to take this equation here, equation B, and we're going to find the x-intercept. Now if I find the x-intercept, y is going to be 0, so the y term is going to be gone. So that equation now with the y term going to be, the y is going to be 0, so that term is going to be gone. So all I end up with is an equation of negative 4x equals a negative 44. So I'm going to divide by a negative 4. So that says my x-intercept is 11. So if this graph were to come out a little bit farther over to 11, 11 would be right here. Well, I also know that the slope here is 2 over 1. So I can't go up and to the right, but I can go down and to the left. So if I go down 2 over 1, that gives me 1 point that's on the graph. Now with that 1 point on the graph, I continue and I can find all the other ones. So down 1 over 2, down 1 over 2, down 2 over 1, down 2 over 1, down 2 over 1. I counted that wrong, didn't I? Down 2 over 1. There's the line for B. So kind of tricky, isn't it? So I can start there and go there. There is the equation for B. And so sometimes if you can't find the y-intercept, you can at least find another point And once you know that one point, you can use the slope to find the other ones that are on the graph. Now, what is that ordered pair right there? Well, that looks like it's 8 on the x and a -6 on the y. So let's go ahead and check this. I'm going to erase this off of here, see what we were doing. So I have a -2, the x is 8, plus 8 times the y is a -6, and that has to equal a -64. So -2 times 8 is a -16, plus 8 times a -6 and -48. We add those two together. Well, we know 6 and 8 is -14, and 10 and -50. So that has to be a -64. Okay, so -64 equals a -64. And that's a true statement. Now let's go ahead and check the other one. So let's do that one over here. So I've got a -4. My x is 8. My y is a -6. And that's supposed to equal a -44. So I have a -24. Nope, that's a -32. Plus a -12 is supposed to equal a -44. -32, that's a -44. Because you have a 30 here and a 10, that's -40. Then you have a -2, and a -2 will give me the 4. So that does equal -44. So that does work. So that's another type of problem that you'll have. Maybe you can't use the y-intercept to graph it, but if you can find one point that's on the graph, look for the x-intercept, and if you can find where that is, then you can finish graphing the problem. All right, we're going to go on to problem 8. Okay, let's go ahead and put each one of these equations in slope-intercept form. So I have y equals, the x term is going to move to the other side and change signs, and it's going to be divided by the 4. So that'll be 3 over 4x. And then the 4 divides the -40, so that'll be a -10. And now for equation B, we know the 5 is going to move to the other side, and it'll change sides in doing that, and then it's going to divide by 4. And then now 4 divided into -24 gives me a -6. So there's equation A, and then I've got equation B. Let's go ahead and graph equation A now. I started at a -10. This is a positive slope, so I go up 3 to the right 4, up 3 squares to the right 4 squares, and then that looks like that's the only, it's as many as I can get. I think I counted that wrong. So 1 2 3 1 2 3 4 1 2 3 1 2 3 4. I think I did count that wrong the first time. So there's where that line goes. So let me go ahead and draw that line. I'm still on eraser there. Okay, so there's line A. Label that line A. And then we'll do B. So line B, I started at -6, and this is a negative slope, and I go down 1 2 3 4 5 over 1 2 3 4. Well, that's off the graph. So what I'm going to do is I'm going to count backwards. I'm going to change this to a +5 and go up, and this to a -4 and go back to the left. So 1 2 3 4 5, then back 1 2 3 4. Then 1 2 3 4 5, 1 2 3 4. So there's that line. Didn't need to do that. So I'm right there on -6, and then I'm all the way up there on that point. So if you look here, this does not have an integer solution. It crosses. Let me zoom in on this and you can see this really easy. It crosses somewhere weird right there. I don't know if this is, I drew it off a little bit, but maybe that's a half. Who knows what it is? So we really don't know what that ordered pair is. So graphing only goes so far, and I think there's a couple of problems, maybe 3 problems on this worksheet that turn out that way, to where when you graph them they don't work. And so that leads us, will lead into the next section where we have to find another way to solve equations where we don't get on an exact point where we know what that ordered pair is as far as its integers. These are going to be rational numbers or fractions. So that's the video to help you with this worksheet. If you have problems with this, we'll just go over them in class and spend as much time as we need to help everyone to learn this. And thank you for tuning in, and have a good evening.